Bernoulli's theorem. If an ideal liquid is flowing in, say, streamlined flow, then the total energy, that is the sum of pressure energy plus kinetic energy plus potential energy per unit volume of the liquid, it remains constant at every cross section of the tube. So you can write it mathematically. Uh, this is for the pressure energy. This is half rho v square for kinetic energy, rho gh for potential energy per unit volume. This becomes constant. This can be expressed in different terms also. You can divide whole equation by rho g. You get this equation. Why we have done this? Because this is the pressure head. This is the velocity head, and h is of course the gravitational head. This one. So for horizontal flow of liquid, these two, if you add them, they has to be, and the addition has to be constant. So this is this is known as the static pressure. This one is known as the dynamic pressure. So therefore, in the horizontal flow of liquid, if P increases, V decreases, and this is vice versa. So the theorem is applicable to ideal liquid. That means a liquid which is non-viscous, incompressible, and irrotational. What are the applications of Bernoulli's theorem? Say the carburetor, paint gun, scent sprayer, atomizer, insect sprayer. The action of all these are based on Bernoulli's theorem. The action of the Bunsen's burner, gas burner, oil stove, exhaust pump, these are all based on Bernoulli's theorem. The mapping or say motion of a spinning ball, that we call as Magnus effect, this is also based on Bernoulli's theorem. The blowing of a roof by windstorm, attraction between two close parallel moving boats, fluttering of a flag, these are also based on Bernoulli's theorem.